In this video, we'll generate the dataset of the logarithm and its trend line and its equivalent in inverse hyperbolic tangent and its Taylor series expansion. We begin with the function itself. So array formula Ln of the x values from 0.1 to 1.9. And we'll chart this. Insert chart. And we use scatter chart. Row 1 is header. And the series, you show the trend line. This is logarithm, so we use the logarithmic regression and use the equation as label. So here's our trend line and the logarithmic equation of the trend line. 0 plus 1 ln x. We continue with the inverse hyperbolic tangent equivalent. So this will be array formula. Let's begin with the ARCTANH. So ATANH h x minus 1. So the quantity x minus 1 divided by the quantity x plus 1. So that's quantity x minus 1 divided by quantity x plus 1. X plus 1. And this is multiplied by 2. So that's 2 times. And enter. But there's no equation on the trend line, so we show the trend line. That is series, show the trend line, the type exponential, logarithmic. For the label, use the equation. Now they're all in the same trend line because their values are exactly the same. And here's the equation. Reposition is at the left. So edit chart, legend, show on the left. So there's a difference. 8.88 times 10 to the minus 17. This is already 0. Plus 1 ln x. We continue with the Taylor series expansion, which is the summation of a times the quantity x minus 1 over x plus 1 raised to the power 2n plus 1, where the value of n is from 0 to infinity. And the value of a is equal to 2 divided by, that's array formula, 2 divided by the quantity 2 times n. That's 2n plus 1. And the series sum. So this is array formula. That is x minus 1 over x plus 1 raised to the power to n plus 1. So the quantity x minus 1 divided by the quantity x plus 1. Where it is raised to the power to n plus 1, where 2n plus 1 starts from 1, incremented by 2n, which is 2, 4, 6, 2. And the coefficient will be this range. I forgot to tell you this, to say the series sum. So it's array formula of the series sum. Series sum, because this is series sum. And the interval or the coefficient will be this range. That's our coefficient A. Their values are almost the same. And the yellow lines are on the yellow points are on the same trend line. But we're missing the equation. So we edit the chart. Series, trend line. We want this to be logarithmic. And we want to show the equation. Now here's the equation. So the equation is 9.73 times 10 to the minus 7, which is almost 0, plus 1 ln x. So Their values are almost the same. Their lines are all collinear. And their datasets are almost the same. So this completes the use of series sum, the Taylor series sum, and its inverse hyperbolic tangent equivalent to generate a trend line of ln x, or the natural logarithm of x.